All right, class, welcome. Today, we're going to break down the core concepts you'll need for your upcoming test on the lexical semantics. We're going to tackle the big question, what does a word actually mean? So let's just jump right in. How do we define what a word means? It seems like it should be simple, but the more you think about it, the meaning of a word can be surprisingly fuzzy. It can change dramatically depending on the context. So for linguists, the real challenge is finding a systematic way to pin that meaning down. Let's just take the word princess. On the one hand, you have Princess Diana, Princess of Wales, a very specific person with a literal royal title. But then you hear someone say, Caroline is a princess, look how beautiful she is. In that case, it's being used metaphorically, right? It's not about royalty at all. This kind of ambiguity is exactly what makes studying word meanings so fascinating and so tricky. So, how do we start to unravel this? Well, our first tool in the toolbox is what we call componential analysis. The whole idea here is to break words down into their basic, fundamental building blocks of meaning. Think of it like chemistry. The idea is to treat a word's meaning like it's a chemical formula. Each little component, or what we call a semantic feature, is a necessary ingredient. You combine them in the right way, and you get the full meaning of the word. For instance, you could break down the word man into 3 core components: plus human, plus adult, and plus male. Now, what's really interesting is when you lay it out in a table like this, we can use a simple binary system, a plus or a minus, to map out the core differences between related words. Just look at the rows for man and boy. The only thing separating them is that one feature for adult. You flip that plus to a minus and boom, you've got a completely different word. It's a really logical way to pinpoint the essential pieces of meaning. And this same method can help us untangle a single word that has multiple distinct meanings. This diagram might look a little complex, but it's a fantastic illustration from Katz and Fodor. You can see the word bachelor right at the top, and then all these branches emerge from it. Each path represents a totally different meaning based on its unique components. This helps us distinguish an unmarried man from a young knight, from someone with a university degree, or even a young fur seal without a mate. It's all the same word, but the components are different. Okay, let's move on to our next tool. This one kind of zooms out. Instead of just looking at individual components of single words, this approach looks at entire networks of meaning by examining groups of related words. Now, this is a crucial distinction, so you'll want to remember this for the test. You have to separate the semantic field from the lexical field. The semantic field is the big abstract concept itself, like the idea of kinship or family relationships. The lexical field, on the other hand, is the specific set of words a particular language, like English, uses to talk about that concept. So words like mother, father, and cousin. And we see these lexical fields literally everywhere. Here's a really simple one: culinary terms. All of these activities here, boiling, baking, frying, they all belong to the same lexical field. They all carve out a specific piece of that larger semantic concept of cooking. But these fields can get way more complex. This model here tries to visualize kinship terms not just as a flat list, but as a 3-dimensional space. It maps out relationships across different axes. You've got generation, gender, and lineality, which is how directly related someone is. This really shows that meaning isn't just a jumble of words, it's a highly structured, multidimensional system. All right, our third approach takes a completely different tack. Instead of breaking words down into smaller pieces, this one tries to find the universal, undefinable core of all meaning, concepts that are believed to be shared across all human languages. This theory, which was proposed by the linguist Anna Wiersbicka, is, well, it's pretty ambitious. It suggests that underneath all the incredible complexity of the world's thousands of languages, there's a small, shared vocabulary for all of humanity. It's almost like a universal language of thought. And these are the supposed building blocks of that universal language. They're called semantic primes or primitives. These are concepts so basic, like I, you, want, think, that the theory says you actually can't define them with anything simpler. They are the absolute bedrock. The idea is that everything we say, no matter the language, is built from a small set of these. This original list has since expanded to about 65 primitives. So why is this important? Because combinations of these universal primitives can actually reveal deep-seated cultural scripts that shape how different cultures communicate. For instance, the English tendency towards suggestion, like saying, you might like to, is rooted in a value of personal autonomy. This contrasts pretty sharply with the directness you might find in Russian, which can value expressiveness, leading to phrases like, "you are wrong." It's like we're all using the same basic ingredients, but following very different cultural recipes. Okay, for our final approach, we're going to look at something that comes not from linguistics, but from cognitive psychology. This theory isn't about logical components or neat fields, but about how our actual minds organize and categorize the messy reality of the world around us. Quick, do a little experiment. Think of an example of a bird. What's the first image that popped into your head? I'm willing to bet you thought of something like a sparrow or a robin, and probably not a penguin or an ostrich or a chicken. So why is that? Well, that sparrow or robin in your head is what we call your mental prototype. It's the ideal, best example of that concept, and you measure all other potential birds against it. Now, a penguin is definitely a bird, but it feels less birdy than a robin because it doesn't fly and doesn't quite match our prototype. So with this theory, meaning isn't about a checklist of features, but about similarity to a core example. And these prototypes are incredibly powerful mental shortcuts. They're the examples children learn first when they're acquiring language. They're what people name first when you ask them for an example of something. Even our dictionary definitions are often based on them. They really do shape how we learn, define, and categorize the world every single day. So, to recap for the test, we've covered 4 major frameworks. We have compositional analysis, lexical fields, natural semantic metalanguage, and prototype theory. But what's the big picture here? What's the main takeaway? I think this quote from the linguist Joss Trier really captures the core challenge beautifully. He said, human meaning can be seen as a continuum arbitrarily divided by specific languages. What he means is that we all experience the same reality, this continuum of meaning, but our individual languages come along and slice up that experience in their own unique ways. And that brings me to the final thought I want to leave you with. If each language builds its meaning from different components, maps different fields, and relies on different cultural prototypes, what does that really mean for the act of translation? Can any word ever be perfectly translated? That's something to think about. Good luck with your studies.